Alrighty, let's see what we got here. Count special triplets medium. Alright, you give an integer array nums. A special triplet is defined as a triplet of indices ijk such that ijk are in increasing order less than n, where n is the length. And nums at I equals nums at j times 2 nums at k, so I is twice, the value I is twice that of j, which is twice that of k. Return the total number of special triplets in the array. Turn it mod 10 to the 9th plus 7. Okay, sure. Do I normally do answer or answer? I think I normally write down answer. Okay. Before I forget. So there should be none here, right? So it should be doubling. 0, 1, 2 works. How's that? Oh, I is twice j, or the ith value is twice the jth value, but also the kth value is twice the jth value. So by transitive property, nums at I and nums at k are the same. So these two are like 2x and this is x, where it's like 2x, 2x is the ordering. Okay. So there should be 0, 0, 0 works. 8, 4, 8 works. 4, 2, 4 works. Okay. Huh. Let me think. This should probably be a linear thing here. Question is, what is the most elegant way of determining this property? 2x, x, 2x. So I think maybe having two sets, like you have a prior value that you're checking for. So a given index, you check the double of that value has been seen. And then if it has been seen, this is now a valid middle value, where the middle value needs to find another, that needs to be succeeded by another doubling value. Okay, so I think this is just a set. Is the start, or let's say the prior set is a set of values. The middle set is a set of values, or let's say prior. Okay, and the middle is a set. So these are all previous values, and this is all possible, or all kind of all values, all valid middle values has where if this is x, has a prior double value, right? So note here, in general, finding ways of having 2x, x, 2x in sequence, if not necessarily contiguous, not necessarily consecutive. Appear in the array. So the middle values are the kind of x values, the not double values. Really? Is it really going to be that big? Oh, it is going to be that big. Because I need to do a count. Interesting. I need to do a count. So actually, I think these need to be default dictionaries. I need to do a count. Default dictionary with ints. This is all previous values. Dictionary for all previous values, and that'd be the key. Dictionary is dictionary where the key is a previous value. And the value that previous number, and the value to that entry in the dictionary is the count. And here, this is actually the number of combinations. This is, yeah, this is another default dictionary. It's the number of combinations. Wow, I just can't type correctly. Dictionary key is valid middle number, and the count here is, or the value is going to be count of combinations. Ooh, is that going to work? It's not going to work. Maybe. I think it still might work. Yeah, it's probably, I'll try it. So for every value, or actually every number in nums, let's see if, I'll first check for prior. If it's not, if that number isn't in prior, well then I can just do default dictionary of that prior should be plus the number of times it says, no, I need to do it backwards. Well, this needs to be the last thing. The number of times this has occurred is incremented by 1. Okay, so the first things first is actually doing the counts. How does this number affect the count of all the special triplets? And that depends on the middle, right? The middle, the number of times the middle has already occurred, then one copy of that is going to be working with this new number. So if, let's say this number is like 4, the number of times the middle 2 has occurred, where the middle 2 has prior of another prior 4, is going to be the number of times this is going to increase the answer. So answer is equal to answer plus middle of this number mod. Okay, so add to total any triplets where this would finish it. Okay, and now add to the middle current. So if this is a 4, then this could be treated as the middle number of an 8, 8, 4, and then there needs to be a following 8. So therefore, the number of times the prior 8s have occurred needs to increase the middle. So middle for this number increases by the prior num times 2. So yeah, and then increase the number of times 4 has occurred. I think that might be it. Simple as that seems. Invalid syntax. Ah, F. Too many F's given. Oh boy, not good, not good. Returning 636. The first 6 should increment this by 1. And then the second time, this 3 should have increased by 2 by how many times 6 has occurred, so the 3 should have been there. And then the last thing, whoops, yeah, that's not right. Its middle is is half the number. It's half the number only if it's even. So I guess here, if I say if num is even, then do that. Okay. Can't. Oh, whoops! I need to do half the number. That was kind of a bad mistake, to be honest. Good thing. Well, I mean, I would have been more careful if I knew that this was gonna not work, or knew that I couldn't do test cases like this. Okay, so decent. Let's see if I can't consider how I would optimize this. I guess if this was a fixed range of values, I can use an array. 10 to the 5th rather than the default dictionary. I wonder if that's faster. Guess it's worth a shot. Okay, so I guess how I would change this would be, say prior is an array of zeros times 10 to the 5th. I guess it could be plus 1 since it's inclusive of the possible value that is 10 to the 5th. And then middle, technically there should be a bound here, but just ignore the fact that this is probably too much space. Okay. I think this is probably correct. See if that changed anything. Oh boy, it was out of range. Oh yeah, this is num times 2. Okay. So if nums is bigger than, if nums is if nums times 2, I can type. Where's the multiplication? Nums times 2 is less than or equal to 10 to the 5th plus 1. Well, I probably should actually give out the number here. This is actually doing the exponentiation too many times. 10 to the 5th, so 5 zeros. 1, 2, 3, 4, 5, 1. 1, 2, 3, 4, 5. 1, 2. Okay, let's see if that works. Might be even slower now that it has to have to do a multiplication inside an if statement. It is in fact slower. Okay, excellent. I mean, I can ignore if I do double here, or actually if I do double here, then I wouldn't have to do the check for the multiplication. Is always going to be within the bounds of that first-sized array, at the cost of memory, to be sure. Although it looks like the memory is just kind of minimal. Okay. Well, am I fine with this? Do I want to try to go even further? So the prior is going to be here I guess this would be the index is equal to the previous number, and the value at that index is going to be the count of that previous number. Then here the index to this array is going to be the valid middle number, and then the value is going to be count of sequences with that prior middle value. Okay. I wonder if if I multiply num mod 2 1 minus num mod 2 1 minus num mod 2 would give me 1 becomes 0, 0 becomes 1. Multiply that by this value. I wonder. Okay, let's see if changing it from a conditional statement to an actual just arithmetic value. This still needs to be wrapped up. So it'd be 1 minus num mod 2 times middle at num divided by 2% mod. I always wonder whether or not these kind of expressions that are equivalent to a conditional actually speeds things up. Negativo. I wonder. I always thought the branch statements would be slower than doing a straight computation, but maybe this is actually, I don't know. Like somehow the computation is as fast as the branching. Well, gave it a shot. Like, if there's no real benefit in terms of speed, then there's no reason to try to make the expression or logic more complicated or more harder to read. Okay, so if an even number increased by half, increase by the number of times you see the middle number prior. Okay. The middle number increases by that. Prior number increases by that. Okay, that's fine. So the slowest or the fastest it went was that. Okay. Summary here is going to be keep track of counts. In particular, iterate over the numbers in the array, and for each number, 1, answer increases by the number of valid if number for each number, consider it as being part of a special triplet. if number were last in the triplet, answer increases by valid middle values, where the middle value is equal to half this current value. So if the current value is 8, then you would increase the answer by the number of valid kind of middle 4s. So, for example, so let's say we'll use as an example, let's say number is 8. Example, increase by valid middle 4s. If number were middle in the triplet, increase kind of the middle for this number by valid prior 16ths. Basically, the start is twice or double the middle of triplet. And then if number were start, increase start. I called this prior. Maybe I should call it the start. Oh, whatever. Prior for this value by 1. Like this is the first time, or it could be the first time, but the number of times this has occurred is increased by 1. So keep 3, or I guess this I just need to keep 2 arrays where index equals some value in the triplet, and the array at that index is going to equal the count of times it can be used as the start or the middle in the triplet. Yeah. Have appropriate logic to increase based on the value, based on the current value. Be careful with the order of logic. You want to definitely increase the prior thing last, the times that this number has occurred at the end before you or after you've referenced it in terms of the number of times the middle value has occurred. Actually, I guess maybe this doesn't really matter because these two values are going to be different. It doesn't matter if num is 0 though. Yeah, because num times 2 is 0. So yeah, this thing should be after this statement that references prior. Okay, and then time complexity, this can be technically should use default dictionary of ints instead of arrays if the range of values in nums is large, like 10 to the 9th. Above solution used arrays as range is kind of small, 10 to the 5th, and array access change is faster than dictionaries or hashes. Dictionaries. Time complexity, this is going to be O of of n, where n is the size of the array, as it needs a pass through each value to determine the sequence, or the count of sequences, count of triplet sequences. And then space complexity, this can be O of n to keep the array of prior / start values and keep track and the array of mid values. I guess the other slight issue was because of the range issue, the prior needs to be twice the actual size of the values here, because if you were to treat a number as the middle value, that'd be half of some prior value, so to not go out of bounds. Yeah. Alright, what